everyone, welcome to my YouTube channel. So in this particular video, I'll talk about something which is pretty much important to understand with respect to whenever you are training your machine learning model. This is, one of the question which is very vastly asked in an interviews as well. At least I can share my experience that in maximum data science interviews, this particular question plays a very important role. That at what kind of scenarios, which particular performance metric you will choose. There are so many, and usually we get confused that at what point of time which particular metric is really important. So in today's video, I'll just talk about this classification problem. So you all know that whenever we are dealing with a machine learning project or machine learning specific problems, so we are dealing with two different kinds of problems, right? So in machine learning, I can divide the problems into two categories. One is something which I will say is a classification part, and the another one is something which I usually classify as regression part. I hope everyone knows this part. When I'm saying classification means, for example, I want to classify that whether a person is having diabetes or not. So either it will be yes or it will be no. Yes means that the person is diabetic. No means the person is having no diabetes. Okay. This is something that we will be able to have whenever we are dealing with something called as classification problem. When I'm talking about regression problem, it simply means that here we want to predict the continuous value. We want to predict something which is a continuous value, right? Which is a continuous value. For example, very simple example which I can give is the house price prediction, right? Very simple. So given the features, if suppose I want my model to give me a value, that will be definitely a continuous value of the price of the house. So house price prediction of a model is a regression problem. Now in today's video, because I don't want the video to be very long, I just want the video to be very short, as well as whatever content I am covering up, it will be pretty much clear to you all. I'll create a separate video for the regression part as well. So when I'm talking about specifically the classification part, there is a very important term which I hope everyone must have heard of regarding the confusion matrix. I hope you guys have heard this term, and the good thing is, and the bad thing is that people are very confused about this confusion matrix. Confusion is actually creating a lot of confusion in the head of so many students. Let me try to, clarify the concept very much easily. Let me try to explain to you the concept very much easily. See, when I'm saying confusion metric, it's a 2x2 matrix where on the topmost side, I will be having the actual values, right? Actual values, that is 1 and 0, because we are dealing with a classification problem. So this, whatever task I am now, as of now explaining, is specific to the classification problem. Okay, is specific to the classification problem only. For regression, I'll create a separate video. As of now, just focus on the classification part. Now, this is something is the actual, and this is something which is the predicted. So this is something which is the actual, and this is something which is the predicted. Now, this kind of two-dimensional matrix is there, where what does this indicate? Let me try to give you one simple example. Suppose we will be having some data set. Inside that data set, you will be having very maybe huge amount of features like x1, x2, x3, x4 until maybe x10. And finally, you will be having the prediction which is a y cap. But I'm talking about a supervised data where you will be having an actual value as well. For example, we are dealing with a diabetes prediction data only. Diabetes prediction data only. So we will be having these x1 to x10 as the input features which I will give to the model and which is responsible to give the predictions that whether a person is having a diabetes or not. Now, either the output will be 1 or the output will be 0. It might happen that the actual value is also 1. Means what I am saying here, the meaning of this particular statement or this particular numeric word is that my model is predicting, y cap is predicting that a person is diabetic, and actually also the person is diabetic. This is something, the scenario which I will call it as a true positive. True positive, which I will represent as TP. In many of the standard books also, you will see this kind of wording, TP. What is TP? True positive. Why I am saying this is true positive? Because the output is positive. So always make sure that you have to see the output. You have to see the model's prediction. That is the value which you have to write in the second case. Okay. The first case is you have to see that whether it's true or it is false. Now, what scenario I am giving to you, that the prediction is also 1, means I am pretty sure that the value will be positive. Now, I have to check whether it is true or false. So, I need to make sure what is the actual data that I have. It is also 1. It means it is called as true positive. So, my model is giving the output as positive. This is P, and it is true. Why? Because the actual data also give me the value as 1. I hope this part is pretty much clear to everyone. Now, same example, maybe the person is, my model is giving the prediction that the person is not diabetic. And the value of y is also 0. Means actually also the person is not diabetic. Prediction is also saying it is not diabetic, means it is saying negative. You know? Person is not diabetic means negative. Now, whether it will be true negative or false negative, you will have to check or verify with respect to the actual value that you have, which is a true negative, because predicted also 0 and actual is also 0. So, this is something that you will call it as true negative. When your predicted is also 0, model's prediction is 0, and actually also your value is 0. I hope that these two wordings are pretty much clear to everyone now, that what is the meaning of true positive and what is the meaning of true negative. Now, let's talk about the remaining two values which is left. Now, consider a case where I am saying that the prediction is 1, means, and the actual is 0. What does that indicate? It indicates that my model is saying that a person is diabetic, but actually the person is not diabetic. So, what is the model's prediction? Always make sure that is something where you will mention positive or negative. Model prediction is positive, but is this prediction which is positive that a person is diabetic is true or false? No, it is false. Can I say why it is false? Because when I'm going to check the value of y, which is the actual value. So this is the actual value and this is the predicted value. This is the predicted value. So if you will observe here, if I will go to check to the actual value, it is 0. So it means I am getting a false positive. So what I am saying, it can happen that your prediction is 1, but actually it is 0. So what is the prediction? It is positive. But is it true or false? It is false. Similarly, the last case where suppose your prediction is saying that a person is not diabetic, but actually that person is diabetic. Actually that person is diabetic. So what is the output? What is the prediction that you are getting? You are getting a prediction of negative. But is this negative is true or false? It is false because my actual is positive. So here again what I will do is that I will check what is the output. It is negative. Now I need to verify that whether it's a true or false. So I will just check the actual value. They are mismatching. So it will be false. First problem which a lot many people faced is filling of this particular confusion matrix. I tried to explain it very conceptually. If you will try to go through the session very much carefully and consciously, you will be able to understand what I am trying to deliver here. Okay. Now, moving ahead, in the classification part, 5 evaluation metrics are pretty much important to understand. The very first is the basic one, which I hope everyone knows, is called as accuracy. Whenever I am talking about accuracy, it is something where what are the values which are actually accurate divided by total number of values which you are getting. Now, actual accurate means how many true positives are there and how many true negatives are there, divided by the summation of all the values, means how many true positives are there, plus how many false positives are there, plus how many false negatives are there, plus how many true negatives are there. So what I am saying, this is something which is the actual good factor, right? In my model, means person is diabetic and my model is also saying the person is diabetic, means true positive case. Or person is not diabetic and my model prediction is also saying that the person is not diabetic. Both of the cases are actually the one which I really want my model to give. This is something which is the accuracy divided by all the 4 values that we have created. Now, in maximum scenarios, you will observe that we are trying to find out the accuracy. But then there are few scenarios where accuracy will not work the best. For example, suppose in your data set, your data is imbalanced data. Your data is imbalanced data. Now, what is the meaning of imbalanced data? Imbalanced data set. Or what is the meaning of imbalanced data? For example, taking the same example, whether the person is diabetic or not, you will be having maybe 100 records, which is quite low. But as of now, let's consider that you will be having 100 records. Out of these 100 records, 90 records belongs to a person who is not diabetic, which is 0. Whereas 10 records belongs to a person who is diabetic. This is something where the distribution is, biased with respect to the person who is not diabetic, with respect to 0. So even if you will just directly pass this particular records and just check the accuracy, even though if for all the test data it will perform 0000, then also you will be able to get an accuracy of 90%, which is too good. If you will check only the accuracy part, which is too good, right? You will feel that your model is doing pretty well. And when you will deploy that model to the production side, a blunder will happen. Because the person who is diabetic also, the model is saying not diabetic. So he or she will suffer with the danger, right? Specifically in healthcare domains, you will feel that there is a problem of imbalanced data. You will feel that specifically in healthcare, a lot of data set is highly imbalanced only. So at that point of time, accuracy is never a good measure because the data is imbalanced. Yes, if suppose I will say that the data is balanced, means 50 records belongs to 0, 50 records belongs to 1, then it is fine. I don't have any issue. But in this specific case, accuracy is not at all a good measure. Then what we should do? We can go for the next important measure, which we called as Preseason. What is Preseason? Preseason means what is the true positive value you will be able to get divided by how many total true predicted values you will be able to get. Means this one. How many total predicted true values you will be able to get, which is nothing but true positive plus false positive. So it will be TP divided by TP plus FP. This is something which we call as Preseason. Remember by the name, whenever we are talking about Preseason, we are focusing on the denominator factor as total predicted values, which are true. And when I'm talking about recall, I am focusing on true positive divided by total positive values with respect to actual data. Means I am talking about the column now. This one. This is something which is true positive plus false negative. So here I am focusing on the actual data. True positive plus false negative. The only difference between Preseason and recall you will observe is here I am focusing on true actual data, whereas in the above case I am focusing on true, I would say, predicted data. Preseason and predicted, there is a resemblance. by which you can remember this thing. Now, one thing which you will observe here, that in Preseason we are focusing on reducing the false positive. Everything is same, right? In the formula, everything is same. But the only difference is that in Preseason, what we really want is when the Preseason will be high, when false positive will be very low. So when I'm talking about Preseason, I'm focusing on a very low false positive. And when I'm talking about recall, I'm focusing on a very low false negative. What does that mean? The simple meaning is that it depends upon the scenarios where you have to choose, where you have to pick that which particular factor is really important to decrease. Let me talk a very specific example. For example, let's talk about recall. For example, we are taking the same example of diabetes prediction. Diabetes prediction. In this case, I am saying that it's really important for me. See, if false positive and false negative both are low, that is a very good model. But there are scenarios where I really want false negative to be low because I don't want to take any risk. For example, in this specific scenario, and this is something which an interviewer can ask from you, that in what scenario you will choose Preseason and in what scenarios you will choose recall as the performance metric. So what I'm saying, in diabetes prediction, if someone will say, I will prefer recall. Why? Because my focus is to decrease the false negative as much as I can so that my recall will be high. Right? Why is that so? What is the meaning of false negative? False negative meaning is that actually the person is diabetic. Correlate with the diabetic scenario. Actually, the person is diabetic, but my model is saying person is not diabetic. This is real danger, right? This is real danger. What I really want, FN, false negative, to be low in that danger. Because specifically in healthcare domain, whenever I'm talking about taking a diabetes example, COVID example, right? When we are checking the COVID RT-PCR cases back in 2020 to 2021, if you remember, when COVID was at peak, so the major focus was to increase the recall. The major focus was to reduce the false negatives. So what I'm saying is that any healthcare example, any healthcare, data set, whenever you are dealing with, specifically when you are doing a classification task on a healthcare data, okay, you can't, take a risk of the lives of people. In that case, accuracy can never be a good measure. The good measure is recall, because objective is to majorly reduce down this false negative. False negative meaning that actually the person is diabetic, but my model is saying person is not diabetic. Actually, the person is having a COVID, but my RT-PCR report is saying I'm not having a COVID. That is something which is a danger case, and which happened back in 2021, right? In the when there are a huge number of reports coming up. So that is something which you have to take care of. So if someone will ask you in an interview at what kind of scenarios recall will be preferable, any healthcare domain data you can say, or you can directly say that in healthcare domain, in healthcare cases, whenever we are doing a classification task, we will always prefer recall. And I hope that now you can explain the reason behind that. Coming towards the Preseason, what do you think? In what scenarios Preseason will be preferable? In Preseason, our focus is to reduce the false positive. I want false positive to be as low as much as I can. For example, if I'll take a spam classification task. Okay? Spam, let me write it below. Spam classification task. So in this scenario, whenever I'm talking about this kind of a scenario, spam classification, what I really want is, I really want false positive to be as low as much as I can. Why is that so? Again, go back to the confusion matrix. What is false positive? Actually, it is 0. Actually, it is 0 means that my mail is not spam. My mail is 0 means that my mail is not actually a spam mail. But my model is predicting that it is spam and it will go inside the spam folder. That is a bigger issue, right? As comparable to the opposite one where my model is saying that it is a spam, and prediction is saying it is not spam. What will happen in worst case in this case? It will go to the important primary folder. It's okay, I'll check and I'll remove, or I will dump into the spam folder. But vice versa case where I am saying that, the mail is not spam actually. It might be some important mail, right? It might be some very, very important mail for me. But my model predicts that it's a spam mail, and this usually happens, right? At least in my case, a lot many important mails. I remember one of the story, there was a result which was coming up few months back with respect to Reliance Foundation scholarship. And when I went to the Red FM interview, just 1 month back, so I told to them this story. So when result came, all the results, displayed. But for me, my mail is not coming up. And I was just waiting for that particular mail. Like whether I was shortlisted or not, at least I should get the mail, right? And then after a few days, I have checked the spam folder because I have connected with the team, and they told me that please check the spam folder. And there the result was there that I was shortlisted. So this is something which is very important for me to know, but it was going inside the spam folder. So that is something which we have to understand here, right? So I hope it is pretty much clear to everyone that how the precision factor is pretty much important in this particular scenario. At least this story will help you to remember now, right? So whenever interviewer will ask you now in what aspect you will prefer precision and in what aspect you will prefer recall, I hope you will be able to deliver the answer pretty well. Now, you can ask me one more question. That, okay, Priya, you have talked about accuracy. You have talked about the scenario where accuracy is not preferable. Then you have talked about precision and recall and the scenario-based things. All thing is good. But there will be scenarios where I might not able to get that which particular, thing is preferable. Means either I should prefer false positive to be low or false negative to be low. In that scenario where you are not sure which particular parameter you should take, which particular metric you should take, go with F1 score. Go with F1 score. F1 score is something which will take a combination of both of them, precision as well as recall. The formula is very simple. Precision into recall divided by precision plus recall. Precision plus recall. So here what is happening is we are taking a combination of both of them. See, there are few scenarios where you are very much sure that, okay, precision is preferable or recall will be preferable or accuracy will be preferable. But there comes few scenarios where you are not sure, you are highly unsure. In that case, go with F1 score. So these are the few, evaluation metrics. These are the few evaluation metrics which I really want to discuss in today's session, because these are the questions which will be definitely asked from you whenever you are going for data science interviews. These are something which is a scenario based questions. Whenever I used to say that, in the interviews with respect to data science, scenario based questions will be asked. People usually don't understand what is the meaning of that. This is what I am referring there, right? So I hope that today's session is pretty much helpful for you all. Basically, we have talked about the model performance analysis, how we can do that with respect to the classification problem. Maybe in the next video, I'll talk about with respect to regression problem. Again, there comes a very important topics like, MAE, MSE, R square, absolute R square. So all those stuffs will come into picture, and at what point of time we should prefer which kind of a performance metric in those scenarios. But let's not take those things into this session, because I don't want this session to be very big, and at the end of the day you will end up not watching the complete session. That's of no use. Please try to watch the video till the end so that everything, whatsoever I am explaining, the concepts will be pretty much clear to everyone. I hope that the explanation is, you find it pretty much easy, and you will be able to understand the concept pretty much well. If you still have any sort of confusion, do let me know. I will for sure try to resolve it as soon as possible. Please hit like button, share the video with all your friends, whosoever is, having confusion in all these concepts with respect to DSA and data science. It will really mean the world to me, because, without your support, this channel will not go to wider audience. And this is what my ultimate target is, right, in the upcoming years. So bye-bye everyone, and I'll see you all in my next upcoming videos.